Hello everyone, today we're finally going to take a look at something that I've been teasing for a while now, the next few PCBs for my 3D printers, to be more specific 5 PCBs from PCBWay. So let's take a look inside, and here they are. So let me show them to you one by one. So yeah, let's begin with this. This is the PCB that will go behind the TinyM. I already talked about the functions of this before, but basically this is a GPIO breakout for the Raspberry Pi, and it also generates 12 volt and 5 volt rails to supply the Raspberry Pi with 5 volts, and also supply 12 volt and 5 volt fans with 12 volt and 5 volt. You do the voltage selection for the fans here using jumpers, similar to the implementation on the 5-stick spider board. And we also have the GPIO breakout, power breakout, I2C, UART, SPI, etc, etc. And this also has two mounting locations for Adafruit clone Max 31865 amplifier boards. So theoretically I can wire up to two PT100 4-wire sensors to this, and that will be really nice. This is the Voron 2.4 bed board. I'll get to this in a second. But to show that, I also need another board that will run to that, so I guess we'll see which one I get here. The Voron 0.1 toolhead breakout board, so it does what it says in its name, so let me zoom in on it a bit. So this has the fan breakout, the thermistor, e-motor, hot end heater, etc. And this will run to this PCB. And so this will break out the pin so that I can wire it to my Duet 2. So it will connect here with an 18-pin microfit connector. And there's also a 2-pin here for a PT100, because as I said in the last Voron 0 episode, I do plan to use that sensor. And the wire limit switch connector here, but most of the business is on the other side. So again, as I said, it has the breakouts for that 18-wire connector that will run to this breakout as well. And on top of that, this also has the 5 volt and a 12 volt power supplies, the same ones that are built into this as well. So the exact same circuitry, so it should, if it works well on that, it should work well on this as well. And yeah, again, it will power the Raspberry Pi, and theoretically 12 volt fans and 5 volt fans as well, which could be important with the Voron 0 down the line as well for the hot end, but not going to get into that too much. This design is based on Timmit's design, so I'm also going to link that in the description below as well. But his is just a breakout, and this one, as I said, has the power circuitry. So that's what's different with this mostly. He also doesn't use the 18-pin microfitted, he uses a smaller one. I think he used 14 pins, don't quote me on that, but something like that. But yeah, I went with 18. So anyway, we will be testing this as well and installing this to the Voron 0 as well, but the extended testing with the firmware and etc, it will obviously be later down the line. And finally, let's take a look at the Voron 2 boards. The Voron 2 boards don't really have anything active on them. It's just a breakout system really, but yeah, let's take a look at them. So firstly, there is this. I showed how this is going to work in a previous video, and I'm going to put an overlay of that on the screen right now. But basically this will sit behind the bed, kind of like the old PCB, but obviously this is much smaller, so it will require a 3D printed piece. And what this will allow you to do is connect the Z limit switch, then recirculating fans below the bed, and the thermistor and the BME 680 to this, and same 18-pin connector that will run behind the printer up to the top electronics chamber. And in the top electronics chamber there will be this. Now this will accept the wires running from the bottom electronics chamber using the terminals here, and the 18-pin connector, which will be soldered on the backside in this case. So just to make wiring easier, obviously the wires will be sticking out from here, so that's why it's designed like that. So yeah, it's the breakout for this obviously, and on top of that the 24 volt and the SSR control from the bottom electronics chamber will be running to this. And down the line, if I want to add a chamber heater or something like that, and if I need an SSR for that, well, there are spare wires as well, and that's why there are 3 sets of terminals pairs that run like this, so that I can connect multiple SSRs if I want to. And here it will run to the MCU for the power as well. As I said, this is also for the 24 volts coming from the bottom electronics chamber. And with the spider I don't need the 5 volt and 12 volt rail, so that will be handled by the spider board. That's why there's nothing for that on here. And these small fonted things, I had to cram them a bit to fit them here. It's the breakout for this, as you might guess. And this video is sponsored by PCBWay. They offer to send PCBs for free, and as you know, I've used PCBWay many times before as well. I'm pretty happy with their service, so I didn't see a reason to refuse. So thanks to PCBWay for supporting this channel. If you're interested in their services, you'll find a link to them in the description below. They offer PCB manufacturing and also 3D printing and CNC machining and stuff like that if you're interested in that. But let's move on to the components for these boards. So here are the components for this. There aren't really many components, as you can see, especially in terms of active components, but I'm also not an experienced electronics designer, so I wanted to be safe. So I just went with off-the-shelf DC-DC converters for this project. So here we have two 12 volt, these 24 volt to 12 volt DC-DC converters. I'll put the current rating on the screen right now because I forgot, but it's not much, but it's more than enough to run fans and LEDs, and well, that's basically all I want a 12 volt rail for anyway. And here, these two guys, these are kind of expensive if I remember correctly, but these are adjustable 8 amp DC-DC converters, and the voltage is, as I said, adjustable with a trim resistor, and these will be the 5 volt rail. And for the Raspberry Pi, obviously you need at least a few amps, so I went a bit overkill and went with 8 amps, but obviously that's the maximum rating. I don't want to run these at that anyway, so yeah, that's why I went with these modules, and I think they will work pretty well. But as I said, these do require a trim resistor, and well, I had one in mind, but yeah, there were some problems acquiring that. I'll get to that, but instead I just went with trim pots. So I have 2 of these Burns brands trim pots that I will use instead of resistors, but the PCBs are designed for the resistor, so there will be a bit of a botch there. But yeah, getting these parts wasn't easy, and the problem was the 12 volt modules. I designed the PCBs for this. Actually, I had an earlier revision with different sets of DC-DC converters, and both of them went out of stock, both on Mouser and on DigiKey, so I redesigned those, and these were in stock, and the last day Mouser went out of stock for these, so I had to order these from DigiKey. And the prices are about the same on DigiKey, but I had to pay a lot of shipping on Mouser is free, and on DigiKey it was like $70 or something, but yeah, what can you do? But another problem was the specific trim resistor that I spec'd that based on the datasheet wasn't available, so I had to go with trim pots. Actually, theoretically, this should be the better decision anyway, since this gives you some adjustability, but yeah, I wanted to just use a resistor and not bother with this, but yeah, as I said, that didn't happen. And as a result, since I designed the Gerbers for these PCBs before that, these have the resistor footprint here, so I'll have to botch these in, as I said, but yeah, I should be able to make it work, and I don't think it will be too ugly, and it should do the job just fine, so shouldn't be a big problem. And there are these 18 pin microfit connectors. As I said, I'm using those for the most of the boards. The straight one here, this is for the Voron 0 PCB, this one that will sit between the Voron 0 motors, so it will sit like this, and if you're looking from the front it will be like this, and this will be in here, so yeah, should give you an idea of how this is going to look. And for the breakout behind the motor of the Voron 0, and for the Voron 2-bit PCB, and for the top electronics PCB on the Voron 2, I'm using the 90-degree one. So yeah, that's the plan. So yeah, I guess let's get to soldering these, and well, hope they work, because as I said, I'm not really an experienced designer, so I guess we'll see. I finished soldering all 5 boards. I actually started recording a time-lapse, but the battery ran out, but I mean, it's good that I didn't record it. It would be a huge file. It took over 2 hours. Honestly, didn't expect it to take that long, but this PCB alone took like an hour, so yeah, I'm also not great with soldering. That's probably part of the reason, but whatever. I did all of the soldering and they're all ready. I'll give you a better look at them But the first thing is seeing if the power supplies are working. So I'm going to calibrate this module, the one that sits between the motors on the Voron 0, and then I'll move on to this as well. If this works, this should work as well, if I didn't damage anything, that is. So I'll just power this on. It's already hooked up to my power supply, which I will be supplying 24 volts from. And just need to do the trim pot adjustments on the 5 volt rail, and also double check that every voltage is present, so 5 volts and 12 volts, not more than that. So yeah, I guess I'll be back with that. Well, good news, it is working. So as I said, I'm supplying 24 volts from here, so let's just see the voltages working. So I might be probing the opposite way, I'm not really sure. Let's see. No, I'm probing the correct way. So 12 volt rail is present, as you can see in the back in the multimeter, and 5 volt. Again, you can see that it's perfectly 5 volt. That's obviously because I adjusted the trim pot, but with load it might drop slightly below 5 volts, since it's just perfectly on 5 volts. So if that's the case, I can just adjust the trim pot a bit higher. 5.1 should still be perfectly fine for a Raspberry Pi. So yeah, anyway, it is working, so time to get this PCB working as well, and the other board is working fine too. So now that we know that everything at least seems to work, now it's time to install these and take a look at how they are going to work. But unfortunately, the full testing of these will take me a while, as I said before. Currently, I don't have a single working 3D printer. All of them have some fault that I need to fix. So yeah, I'll basically install them, but testing will take some time. But I'll definitely give you a close look at them, and you will see more information about these PCBs in their own 3D printer series. So let's start with the Voron 0. And in my opinion, this is the most interesting one, and I definitely stole the idea of the cover PCB from Timmit, as I said. But this is how it's going to look, the PCB between the motors. So from the front, you won't really see any components on it. I think I'm going to design some sort of 3D printed cover, just so you don't see the leaded components legs poking through. That kind of looks ugly, especially with my soldering job. So yeah, I think I'm going to design something to cover those, but other than that, it's going to sit there like you see. And you'll notice that I have the wire coming from the wide limit switch cut. I used to run that to the duet Wi-Fi directly with the aluminium plate in there. But with this PCB, I didn't design a route for that. Instead, I made the PCB a pass-through PCB, so you'll notice the 2-pin header behind that. So that's where the limit switch will connect, and on the other side, there is a connector for that as well. And it will also have the PT100 sensor behind the 18-pin connector. And as I said, the 18-pin will run to the breakout, which I'll give you a closer look in a bit. There might be some problems with that, unfortunately, but yeah, we'll get to that. But let's finish the cover PCB between the motors. So this cutout in the back, that's for the Bowden tube. You might have already figured that out, but still worth showing. So that's how the Bowden tube is going to run, and I will zip tie it and maybe even sleeve it with the 18-pin cable that will run to the toolhead breakout board. And the Bowden tube will obviously go to the back electronics chamber, and from that to the side mounted spool holder, or I might redesign a top mounted spool holder down the line as well, just like I did with the Voron 0.0. But yeah, currently I'm trying to build it mostly stock, and then we'll see from there. And on the bottom, as I said before, there are the breakouts that I described, and there are two sets of 2x3 pin headers. Those are for the voltage selection of the hot end fan and the layer fan, so you can select 24 volt, 12 volt, 5 volt, and that might be important down the line, especially if I have to use weird fans with the toolhead, like the 3007 fan and possibly something else down the line. So yeah, it's good that I have that selection there. And the terminals, those are for the heater input, 12 volt, 5 volt outputs. So the 5 volt will run to the Raspberry Pi, 12 volt I don't think I'm going to use, and 24 volt and the heaters are obviously inputs that will either power the buck converters or run to the toolhead, depending on what they are obviously. And all of this, as I explained, will run to the breakout on the toolhead behind the extruder motor. And here's where we have some problems. I'll have to try to design a different 3D printed part for this. The current cable strain relief design, the spacers for that don't work for my PCB. I had to use a M3 standoff for this, and that's probably going to be too tall. So I've seen Timmit's PCB on that other side work fine, so I'm sure there is a way to fit it, but I don't think the current setup will, so I'll have to design a new 3D printed part, and with that I think I can get it to work. But yeah, I guess we'll see in the next Voron 0 episode. But moving on from the Voron 0 PCBs, there is the PCB I designed for the Tiny M. So this is the PCB that will sit in the back electronics chamber with the power supply and the SKR Mini E3 V2.0 and the Raspberry Pi. So the 24 volts from the power supply will run to that single terminal on the PCB, and the Raspberry Pi, I'll have that IDE style. It's not actually IDE, it doesn't have the pin blocked, but other than that it looks like an IDE cable. This is just a ribbon cable for the GPIO. Will run to the breakout port as well, and that will provide a GPIO breakout, SPI, UART, I2C, and it will also let me connect the PT100s to the Raspberry Pi's SPI directly, so I will be using Raspberry Pi MCU there. If you pay attention to the picture, you might notice that the ribbon cable isn't fully seated on the Raspberry Pi side. That's because of the heatsink that I have on the Raspberry Pi, so I will just have to remove that and use a normal smaller heatsink for the Raspberry Pi. Still should be more than enough, since I do plan to have active cooling in that chamber, but so I just need to remove that heatsink and it should work. The pin headers next to the GPIO outs are for the power outs, so there are 5 sets of with ground obviously, so 5 pairs, 24 volt, 12 volt, 5 volt and 3.3 volt. The 3.3 volt will come from the Raspberry Pi, so I don't have a 3.3 volt buck converter, but the rest will be generated on board, as I explained before. And on the top there are 4 sets of power connectors with individual fan voltage selection, similar to the Voron 0 ones, but this time 4 fans. So again, I can select 24 volt, 5 volt and 12 volt, and depending on what I need obviously. So that's how that's going to work. Below those I have the fan inputs, so that I can control those 4 fans, and next to that I have I2C, UART and SPI, so the buses from the Raspberry Pi, and below that I have 2 4-pin PT100 inputs that will connect to the MAX31865 boards that I plan to have on the bottom side of the board, but I currently don't have those, so I haven't populated them, but yeah, they should work. And as I said, I plan to use Raspberry Pi MCU for them. I used that many times before, I know it works, so I don't expect any problems there. Fusion 360 definitely isn't a buggy mess. This PCB is definitely supposed to be much larger than my Voron 2. And yeah, that's a really micro, nano Voron 2 Doom Cube. Yeah, Fusion 360 for you. Anyway, I think I can still explain what's going on, and I think I'm better off explaining the Voron 2 PCBs in CAD, because I won't be able to install them to my Voron 2 in my Voron 2's current state. So yeah, it just makes more sense to explain in CAD. So there we go. Imagine the PCB that I showed before is here. So yeah, the 18-pin connector on that will run to the top electronics chamber. The PCB there will have the Z limit switch connector, PT1000 for the chamber ambient temperature, a recirculating fan connector so that I can put probably 2 50-15 fans below the bed, and the purpose of that is to recirculate the air, as the name might suggest. And the reason for that is with that you can reach much higher chamber temperatures. Basically your bed acts as a chamber heater in that case, without actually being an independent chamber heater, so still functions the same, and that fan is basically the fan of the chamber heater. So yeah, with a fan you can reach much higher chamber temperatures, at least that's what I've read. And it also has a BME 680 connector. BME 680 is a temperature, humidity and fog sensor. I made a video about that before, making a portable air quality monitor. And with that I plan to measure the chamber temperature and humidity, but also if I can get it to work with Clipper Vox. That's a part of that sensor that I'm not 100% sure if Clipper supports or not. I know it supports temperature and humidity, but we'll see about Vox. But I'd like to measure that just so I can get an idea if the Nevermore Max air filter is doing anything or not. But yeah, I guess we'll see. And as I said, that will have an 18-pin connector running to the top electronics chamber, and from the bottom electronics chamber, which will have the power supply, now single not plural since I got rid of the 5 volt and the 12 volt, but it's definitely not organized like this. I showed the a more up-to-date version of that in the last Voron 2 episode. So it will have the 24 volt wires and the SSR wires running from the top chamber, and there's 4 more spare wires, and all of that will connect to the top PCB. Again, that's actually a different PCB, not this, but I already showed you what it looks like. And it will provide the power for the spider board. The spider board will generate the 12 volt and the 5 volts, so that's why there are no buck converters on these, because the spider board already has them. So I'll just provide 24 volts to that, and the 5 volt on the Raspberry Pi will be provided from the spider board. And there are 3 pairs of pass-throughs. One is for the SSR for the bed, the other 2 are unused. They're basically a remnant of the 12 volt and a 5 volt power supply I had in the electronics chamber back then. Now they're still there, since I didn't see a point of getting rid of the cable itself, so they might as well sit there and possibly be used down the line, maybe for a chamber heater or something like that. But yeah, I don't know what for exactly. It's just there for future expansion. And it also provides the breakouts for the bed PCB, so the the Z limit switch, the thermistor, the BME 680, etc. I had to cram those in there because I didn't have enough space, but yeah, I still managed to make them work, so it shouldn't be a problem there. So those are all the PCBs that I have right now. All the PCBs are here and they're all soldered and they all seem to work, so stay tuned for those in the later Voron episodes, or the TinyM. I guess that's also a Voron. So yeah, that's it for this video. I hope you found it interesting. If you did, please leave me a like down below and stay tuned for the future videos. And thanks for watching.